3I Atlas is an interstellar visitor, yet its visibility to observers on Earth has been extremely limited. Telescopic records confirm that the object follows a steeply hyperbolic orbit, approaching the solar system at a high velocity and quickly departing beyond the reach of most observational instruments. Standard models explain its brief appearance as a consequence of its immense speed and the relative geometry of the Sun, Earth, and comet. However, even with these explanations, Atlas remains unusually difficult to track, prompting curiosity and speculation among astronomers. Observations indicate that Atlas is moving on a trajectory that keeps it largely in the outer solar ecliptic plane, only briefly intersecting regions where ground-based telescopes can detect it. Standard interpretations point to the natural randomness of interstellar ejection paths. Yet some insiders, speaking anonymously, quietly note that the timing of its closest approach coincided with gaps in scheduled sky surveys. Could this have been mere coincidence, or is there an unknown factor influencing when and where the object becomes visible? The data do not clarify. Brightness measurements further complicate detection. Atlas displays low intrinsic luminosity, and its small size means it reflects very little sunlight. Even when passing relatively close to Earth, its magnitude barely enters the detection limits of most telescopes. Some researchers speculate privately that this low visibility could be more than just a consequence of size and albedo. Could the object's surface properties, its ice composition or dust layer, absorb more light than expected, making it almost invisible to casual observation? While the spectroscopic data provide clues, subtle anomalies remain difficult to interpret fully. Tracking anomalies also fuel quiet debate. Early radar observations produced incomplete datasets, and some optical measurements were reprocessed or delayed in public release. Official explanations cite instrument sensitivity and calibration corrections. Yet a few anonymous sources hint that the raw observations may have contained faint but unusual deviations in trajectory or brightness patterns. Why these original data were not fully disclosed remains unexplained, leaving room for conjecture. Visibility is further constrained by observational geometry. Atlas's trajectory carries it toward regions of the sky often obscured by the sun or low horizon angles from major observatories. Standard modeling accounts for these limitations, but the timing and position of the object's approach still present surprising challenges. Some astronomers quietly speculate that the orbit may have been influenced by minor gravitational interactions during interstellar travel, producing subtle deviations that make its detection even more difficult. Could hidden factors along its path have effectively masked it for more continuous monitoring? The evidence is too limited to conclude. Despite these difficulties, Atlas offers an invaluable observational opportunity. Its fleeting appearance highlights both the precision required to detect interstellar objects and the challenges of interpreting incomplete data. While standard explanations suffice for most of its elusiveness, observation gaps, delayed releases, and subtle anomalies encourage speculation. Could Atlas's trajectory and near invisibility hint at unknown influences or deliberate avoidance? Or is it merely a consequence of cosmic geometry and instrument limitations? For now, 3I Atlas remains a shadow in the sky, seen only briefly, studied incompletely, and leaving observers with as many questions as answers. Its passage reminds us that the universe is vast, unpredictable, and often only partially revealed, teasing humanity with glimpses of objects that have traveled billions of years to reach us while maintaining part of their mystery. Tracking 3I Atlas presents extraordinary challenges for astronomers. The object's high hyperbolic velocity, exceeding 100,000 kilometers per hour, means that it spends only a brief period within the observational range of ground and space-based telescopes. Standard explanations attribute this to its interstellar origin. Ejection from a distant star system naturally results in rapid, unpredictable motion. However, some researchers, speaking anonymously, quietly point out that even small deviations from predicted ephemerides can drastically reduce detection opportunities. Could these subtle anomalies indicate external influences acting on Atlas during its journey, or do they merely reflect measurement uncertainties? The truth remains elusive. Brightness is a critical factor. Atlas has a small diameter and a low albedo, reflecting very little sunlight. Even at its closest approach to Earth, its apparent magnitude barely crosses the detection threshold of most observatories. Observational campaigns were quickly organized, yet gaps in monitoring occurred at critical times. Official statements cite equipment downtime and weather interruptions. Yet some insiders whisper that the timing of these gaps raises questions. Could it be coincidence, or did some factor obscure the comet's visibility during its peak approach? No confirmation exists, leaving an open-ended puzzle. The comet's trajectory also creates inherent observational blind spots. Its path keeps it close to the sun's glare for parts of its journey, making detection nearly impossible with optical telescopes. Some astronomers suggest that these limitations are natural and unavoidable, yet a few quietly raise the possibility of more unusual causes. Could Atlas's orbit have been influenced by interactions in interstellar space that subtly altered its path, placing it in regions of the sky where it is difficult to observe? Such hypotheses cannot be verified with the existing data, yet they spark curiosity. Radar observations provide additional intrigue. Initial radar returns were limited, and some data were temporarily withheld from public releases. Officially, this was due to signal noise and calibration issues. However, several anonymous sources hint that the raw data may have included minor velocity deviations and surface reflections inconsistent with a simple icy body. If true, these features might reveal unusual material properties or internal structures. Why the data were partially restricted remains unexplained, feeding speculation among astronomers and enthusiasts alike. Even the timing of coordinated observation campaigns adds to the mystery. Global observatories synchronize their efforts to capture Atlas during its brief visibility window, yet some telescopes failed to provide usable data at critical moments. Official explanations cite cloud cover, technical glitches, or scheduling conflicts. Yet in online forums and informal discussions among professionals, there is a subtle suggestion that these simultaneous gaps may have been more than mere coincidence. Could an unknown factor, cosmic or otherwise, have conspired to keep parts of Atlas hidden from observation? The question lingers without resolution. In the end, 3I Atlas remains an elusive traveler. Its high speed, low brightness, and trajectory combine to make it a fleeting target for even the most sophisticated telescopes. Observation gaps, data anomalies, and unanswered questions leave scientists and the public alike fascinated and cautious. Whether its near invisibility is purely natural or hints at unknown forces is uncertain. Atlas reminds us that even in our era of advanced technology, the universe can still conceal its travelers, offering only glimpses and leaving room for speculation and wonder. The trajectory of 3I Atlas is one of the most intriguing aspects of its interstellar journey. Observational data confirm that it follows a sharply hyperbolic orbit, with an inclination that diverges significantly from the plane of the solar system. Standard astrophysical models explain this as the natural result of ejection from a distant star system, but subtle irregularities in its velocity and direction have prompted quiet debate among astronomers. Measurements indicate that Atlas exhibits small but consistent deviations from predicted positions over short timescales. These discrepancies are minor, within the margins of error for high-velocity interstellar objects, yet they persist across multiple observations. Official interpretations attribute this to outgassing effects and minor gravitational perturbations. Still, several anonymous researchers suggest that these anomalies could hint at additional forces influencing its path. Could there be interactions with unseen interstellar material, or even unknown gravitational phenomena? The precise cause is unresolved, leaving room for speculation. The comet's close approach to the inner solar system adds further mystery. During this phase, Atlas briefly became accessible to optical and radar instruments, yet the observational window was extremely narrow. High-resolution imaging captured fleeting details of its motion, revealing subtle accelerations inconsistent with purely natural sublimation forces. Some insiders quietly theorize that these accelerations may point to internal structural properties affecting its trajectory, or more provocatively, the presence of controlled forces, whether natural or artificial in origin. None of these interpretations can be confirmed, yet they persist as a topic of quiet discussion. Another factor complicating visibility is Atlas's rapid movement across the sky. Observatories reported that tracking it required unusually precise calculations, and even minor timing errors resulted in lost frames or incomplete coverage. Standard explanations cite the challenges of fast-moving, low-luminosity objects. However, some astronomers privately speculate that the object's speed and path may not be entirely coincidental, suggesting that the trajectory was shaped by processes beyond conventional modeling. Could the comet's journey have been subtly guided by gravitational influences in its parent system, or even by unknown mechanisms encountered en route through interstellar space? These questions remain unanswered. Observation gaps amplify the intrigue. Certain radar and optical datasets were temporarily restricted or reprocessed, with official reasoning citing technical corrections. Yet rumors persist that the original data may have shown unexpected features, slight trajectory bends, or unusual reflective properties, before being adjusted for public release. Why these adjustments were made is unclear, leaving observers to speculate. Could there be aspects of Atlas's path intentionally obscured, or is this simply a consequence of standard data handling protocols? The ambiguity fuels curiosity. In summary, the trajectory of 3I Atlas is both scientifically illuminating and subtly mysterious. Its hyperbolic orbit, small deviations, rapid movement, and observation anomalies challenge researchers to reconcile theory with observation. While natural explanations account for much of its motion, minor inconsistencies and gaps in data invite alternative interpretations. The path of Atlas remains a fleeting glimpse into the interstellar unknown, a shadowed trail that encourages debate, speculation, and continued observation, leaving its full story tantalizingly out of reach. The visibility of 3I Atlas is extraordinarily limited, even for modern observatories. Its small size, low reflectivity, and rapid movement across the sky combine to make it a fleeting target. Observations confirm that at its closest approach, Atlas barely reached the detection threshold of most optical telescopes. Official explanations focus on its intrinsic faintness and the short duration of its passage. However, anomalies in observational coverage have fueled quiet speculation within the astronomical community. For instance, several scheduled observation windows coincided with the comet's brightest predicted moments, yet no images or data were recorded. Standard reasoning attributes this to poor weather conditions, equipment downtime, or logistical conflicts. Yet insiders, speaking under anonymity, note that the timing of these gaps seems unusually convenient. Could there be other factors, perhaps even subtle forces along Atlas's trajectory, that rendered it more elusive at key moments? The lack of concrete explanation leaves room for conjecture. Brightness fluctuations provide another layer of mystery. Atlas displayed minor, but measurable variations in its apparent magnitude that did not always align with predicted sublimation models. Some astronomers quietly suggest that these fluctuations could indicate non-uniform surface composition or irregular shape. Others go further in speculation, hinting at internal structures or surface coatings that absorb light unusually efficiently. These possibilities cannot be confirmed with existing data, yet they persist in informal discussions and online forums. Radar observations also contribute to the enigma. Initial radar returns were faint and inconsistent, sometimes failing entirely despite the comet being within range. Official statements cite technical issues and weak signal returns due to the small cross-sectional area of Atlas. However, a few anonymous sources hint that raw data may have revealed subtle surface features or unusual reflective properties that were later smoothed out in processed images. Why these original observations were not widely released remains unclear, adding to the mystery. Geometric factors further limit visibility. Atlas's hyperbolic trajectory kept it near the sun's glare from the perspective of many major observatories, forcing tracking efforts to rely on brief windows of opportunity. While standard astrophysics can explain this alignment, some researchers quietly speculate that the timing and orientation of its passage are oddly convenient, as if the comet were designed to remain mostly unseen. No evidence exists to support such a claim, but the coincidence remains notable. Finally, its fleeting appearance in the night sky underscores the difficulty of interstellar observations. Even with global coordination, Atlas could only be observed for a short period, and much of its journey remains unmonitored. These constraints, combined with subtle anomalies in brightness, trajectory, and radar returns, have led some to suggest that we are only seeing a partial story. Could there be hidden aspects of Atlas, obscured intentionally or incidentally, that would alter our understanding if fully revealed? For now, the question remains open. In conclusion, the elusive visibility of 3I Atlas is a combination of natural factors and unexplained anomalies. Its faintness, rapid motion, observation gaps, and subtle data irregularities make it difficult to study comprehensively. Whether this near invisibility is purely accidental or hints at more complex, hidden influences is unclear. Observers are left with fleeting glimpses, tantalizing hints, and unanswered questions, reminding us that the universe can still conceal its travelers, even in an age of advanced technology. Observing 3I Atlas required extraordinary coordination across multiple observatories and instruments worldwide. Despite these efforts, significant gaps remain in the dataset, raising questions about the completeness of our understanding. Telescopes recorded Atlas only intermittently, and radar systems often returned incomplete signals. Official explanations cite technical limitations, the comet's small size, low brightness, and rapid motion. Yet, subtle irregularities in both timing and coverage have sparked quiet discussions among astronomers and enthusiasts alike. Some optical datasets show missing frames at moments when the comet should have been brightest. Weather interruptions and equipment downtime are the standard explanations, but anonymous insiders note that the pattern of these gaps appears unusually systematic. Could these omissions be purely coincidental, or might they hint at underlying factors that rendered Atlas less observable at critical moments? The official record remains silent, leaving room for speculation. Radar tracking added both clarity and mystery. Atlas's small cross-sectional area meant radar signals were faint, producing only weak returns. Calibration and signal-to-noise issues were officially cited as the cause for sporadic or absent readings. However, a few researchers, speaking off the record, suggest that the raw radar data may have contained anomalies inconsistent with standard icy bodies, slight deviations in velocity, or unusual reflections. Why these aspects were smoothed out or delayed in public release is unclear. Could there be subtle, unexplained features of Atlas's surface or structure that were intentionally withheld, or was it simply a standard procedural correction? The answer remains uncertain. Another complicating factor was the hyperbolic trajectory itself. Atlas moved so quickly across the sky that even precise ephemerides could not guarantee consistent observation. Small prediction errors resulted in telescopes missing the comet entirely during short observation windows. Some astronomers quietly note that these misses coincided with the comet passing regions of the sky that were otherwise difficult to monitor, such as areas near the sun's glare or low on the horizon. Was this entirely a matter of geometry and timing, or could other, unknown factors have influenced both trajectory and detectability? The data cannot resolve this question. Brightness variations further confounded observation. Atlas exhibited fluctuations in magnitude that did not fully align with standard models of sublimation-driven outgassing. While most researchers interpret this as natural surface irregularities or rotational effects, others quietly speculate about less conventional explanations. Unique surface chemistry, reflective anomalies, or even internal structures affecting light scattering. These remain purely speculative, but they illustrate the lingering gaps in our knowledge. In the end, 3I Atlas challenged the limits of our observational capabilities. Instrumental gaps, missing frames, radar inconsistencies, and brightness anomalies collectively create a puzzle that is only partially solved. Was its elusiveness purely natural, a consequence of high speed, small size, and geometric limitations? Or could there be hidden factors, either physical or otherwise, that shaped what we could and could not observe? For now, Atlas remains partly hidden, leaving observers with tantalizing glimpses and open-ended questions about an interstellar visitor that seemed determined to keep its secrets. Despite extensive observations, 3I Atlas exhibits subtle anomalies in its motion that continue to puzzle astronomers. Its hyperbolic trajectory is well documented, but minute deviations from predicted positions have been repeatedly noted. Official explanations often point to natural factors, outgassing, rotational effects, and gravitational perturbations from planets. Yet these deviations, while small, persist across multiple datasets and observatories. The consistency of these anomalies has sparked quiet discussions among some astronomers who remain cautious but intrigued. Velocity measurements indicate that Atlas experienced minor accelerations that are not fully accounted for by traditional models of cometary physics. These variations are modest, typically only fractions of a meter per second. Yet over interstellar distances, they are significant enough to slightly alter its predicted path. Some researchers propose that irregular outgassing events could explain these changes, but others quietly suggest alternative possibilities. Could there be unknown interstellar forces at work, or might the object possess internal properties affecting its trajectory? The data offer hints, but no definitive answers. An additional puzzle lies in the angular momentum of Atlas. Observations of its rotation suggest a spin rate that appears unusually stable, given the expected influence of sublimation torques. Some scientists speculate that the object's shape or composition may contribute to this stability, yet there is room for alternative interpretations. A few anonymous experts have even raised the question, without evidence, whether such stability could be a result of artificial modification or a natural mechanism far more complex than anything observed in typical comets. These suggestions remain speculative, but they add a layer of mystery to the object's motion. Radar and optical tracking also provide incomplete insight into Atlas's dynamics. Certain observation windows, particularly during closest approach, failed to capture all predicted positions. Standard explanations cite technical issues, timing errors, or interference from nearby celestial bodies. However, several insiders have noted that the missing or ambiguous data could hint at unusual acceleration patterns that were simply not reported. Why these anomalies were not fully disclosed remains unclear, leaving the door open to alternative interpretations. Another intriguing aspect is the comet's path relative to interstellar space. Calculations suggest that Atlas passed through regions where gravitational forces from unseen masses or interstellar medium density variations could subtly influence motion. While this is a natural explanation, some theorists quietly propose that such interactions may have been more significant than accounted for, possibly altering the trajectory in ways we cannot yet model. Could these interactions mask hidden properties of the object, or even conceal traces of a more complex origin? The question remains open. In summary, 3I Atlas's motion presents a delicate puzzle. Its slight deviations, rotational stability, and incomplete datasets combine to form a portrait of a celestial visitor that is both familiar and subtly enigmatic. While conventional physics explains much, small inconsistencies and observation gaps leave room for speculation. The comet's journey challenges astronomers to reconcile data with theory and reminds us that even in our era of precise measurement, the universe can retain secrets. Whether these anomalies are merely natural quirks or indicators of something more extraordinary is a question still unanswered. The surface and composition of 3I Atlas add further layers of mystery to its detectability. Spectroscopic observations confirm that, like many comets, it contains ices, dust, and organic compounds. However, subtle deviations in the intensity and ratios of observed spectral lines have puzzled astronomers. These minor inconsistencies do not fit neatly within established models of interstellar comet composition, prompting cautious discussion. Official interpretations attribute these anomalies to measurement noise or the effects of solar radiation on volatile substances. Yet some researchers quietly speculate that these spectral oddities may reveal unusual surface chemistry or structural properties that differ from typical comets. Photometric analysis also reveals minor irregularities. Atlas exhibits a light curve that fluctuates more than expected for a small, irregularly shaped body rotating in space. The variations are subtle, but they have led to conjecture about the surface's reflectivity and heterogeneity. Could there be regions with unusually high absorption or reflective properties? Some anonymous sources suggest that these variations might hint at layered composition or embedded materials not commonly found in natural comets. While such ideas remain speculative, they illustrate how even small anomalies in observation can inspire imaginative interpretations. Radar returns further complicate the picture. Atlas's radar signature is faint and inconsistent, occasionally producing echoes that are slightly stronger or weaker than expected. Standard explanations cite signal noise and the small size of the object. However, a few experts note that the radar inconsistencies might indicate non-uniform density or internal structure. Were these features accidental, or could they reflect a more complex origin for the comet? The official datasets offer no definitive answer, leaving the matter open to conjecture. Brightness and sublimation patterns provide additional intrigue. Atlas shows minor bursts of activity inconsistent with simple solar heating models. These outgassing events are subtle but measurable, and their timing does not always correspond perfectly to distance from the sun. Some astronomers propose that internal pockets of volatile material or irregular structural features could cause this behavior. Others, speaking anonymously, suggest the possibility of something even less conventional: subtle mechanisms or compositions that control outgassing in ways not yet understood. The lack of direct evidence keeps these ideas speculative, yet they continue to circulate in informal discussions. Observation gaps further fuel questions about Atlas's composition. Several high-resolution datasets were partially withheld or reprocessed before public release. Official explanations cite calibration and image quality issues. Yet the timing of these adjustments, coinciding with periods of peak observation, has sparked quiet speculation among some observers. Were unusual features captured and later modified, or is this merely a coincidence of standard data handling? No authoritative answer exists, leaving curiosity unresolved. In the end, the surface and composition of 3I Atlas remain only partially understood. Spectral anomalies, photometric irregularities, radar inconsistencies, and unusual outgassing patterns all hint at complexities beyond typical comet models. While natural explanations account for much, small deviations and gaps encourage ongoing speculation. Atlas remains a mysterious visitor from another star system, its hidden features challenging astronomers to question assumptions and explore possibilities, leaving the full story tantalizingly out of reach. Even after extensive observation campaigns, much about 3I Atlas remains shrouded in uncertainty. Its hyperbolic trajectory, fleeting visibility, and subtle anomalies in motion and brightness provide a wealth of data. Yet gaps in coverage and inconsistent measurements leave many questions unanswered. Telescopes and radar arrays captured only a snapshot of its passage, creating an incomplete portrait of this interstellar visitor. Official accounts emphasize natural explanations for missing data, citing technical limitations, observational constraints, and the small, fast-moving nature of the object. Still, the patterns of these gaps have sparked quiet curiosity and speculation. Certain high-resolution datasets were withheld or reprocessed before public release, raising eyebrows among astronomers. Standard reasoning attributes this to calibration corrections and image quality issues. Yet some anonymous sources suggest that the original data may have hinted at unusual features, unexpected accelerations, irregular reflective properties, or transient structural details. Why these features were not shared openly remains unknown. Could there have been something unusual in Atlas's structure or behavior that observers chose to obscure, or is this merely standard data handling? The uncertainty leaves space for speculation without confirming any particular theory. Another layer of intrigue comes from the timing and coordination of global observations. Many observatories scheduled for peak viewing reported unexpected difficulties, from equipment malfunctions to lost frames. While such issues are common in high-precision astronomy, the repeated coincidence across multiple sites invites curiosity. Some insiders quietly propose that these failures may mask subtleties that would otherwise challenge conventional explanations. Were these purely incidental, or could Atlas's trajectory and composition have conspired with observational constraints to remain partially hidden? The question cannot be answered definitively. Spectroscopic and photometric analyses also hint at complexity. Atlas's faint but detectable light variations, slight spectral anomalies, and inconsistent outgassing patterns suggest a composition and surface behavior not fully captured by existing models. Official interpretations rely on standard cometary physics, yet minor discrepancies remain. Some researchers speculate cautiously that these deviations could point to unusual internal structures, heterogeneous composition, or even processes not commonly observed in natural interstellar objects. Such ideas are not endorsed publicly, but circulate in informal discussions, contributing to the mystique. Finally, Atlas's rapid passage through the inner solar system left little time for repeated or redundant measurements. Even when observed, instruments captured only brief snapshots, often separated by hours or days. This fragmented dataset ensures that some properties, behaviors, or anomalies may never be fully documented. Could there be subtle features in Atlas that eluded detection entirely, or patterns in its motion or brightness that remain hidden in the data we never acquired? We simply do not know. In conclusion, 3I Atlas remains both a source of rich scientific information and a puzzle of unanswered questions. Its motion, visibility, and composition provide intriguing data, but gaps, anomalies, and reprocessed datasets leave much to the imagination. Whether these uncertainties reflect natural limitations, subtle complexities, or something more enigmatic is unknown. Atlas's journey reminds us that even in an era of advanced observation, interstellar visitors can maintain their secrets, leaving humanity with tantalizing glimpses, partial stories, and open-ended questions about the universe beyond.